Okay. So is it visible to all of you?
Yes, sir.
Okay, all right.
Yes, sir.
So this particular portion of the table actually gives you those numbers that we call the eigenvalues. Remember, eigenvalues are those numbers which I had mentioned here in step number 2, right? If you remember, I was talking about eigenvalues. These are actually the numbers which are computed from the correlation matrix using certain expression. And they are actually mentioned over here in this column. Because we have 5 variables, so initially we would get as many components, principal components. So corresponding to each component, you would have these numbers. These numbers are arranged in decreasing order of their magnitude. So the first number, which we call the first eigenvalue, would be the largest in magnitude, followed by second, third, and so on. As you can see, the last one is the smallest of all. Using this determinant equal to 0, which we call this one as the characteristic equation, you will get different values of lambda, and the number of lambda values, which we call the eigenvalues, would depend on the size of this R matrix. By size, I mean, for example, if this is a P cross P matrix, then there would be P values of lambda. In the given case, this R is 5 cross 5 matrix because we are having 5 original variables. So there will be 5 values, as you can see here, okay? Using these eigenvalues, the software then come up with another set of numbers that it called the eigenvector. So corresponding to each one of them, the first, the second, the third, it will actually compute the corresponding vectors that we call the eigenvectors, which would be actually the solution of this equation. The eigenvectors are the solution to something like this. R AI, okay, where AI is a vector, will be equal to lambda I AI. So what would be AI vector? This would be a vector corresponding to lambda I, which means if you put lambda 1, 2.437, okay, in this expression, you will get A1 vector. If you put lambda 2, the second eigenvalue, 1.407 over here, and you will get the second eigenvector. So A1, A2, and so on would be the eigenvectors which will be obtained by this expression, right? So the software will implement first this expression to get the numbers that it called eigenvalues, these, and then using each of the eigenvalues, each of the numbers in this list, it will get the corresponding vector that it will call the eigenvector. If you don't have a very clear idea of eigenvalues and eigenvectors, take it for granted for the time being. In one of the other lectures, I would give you the actual meaning of these concepts. So because there are 5 eigenvalues, so this function.
Yes, excuse me, sir.
Yeah.
Yes, sir. बिल्कुल सर, ये आइगन वैल्यू और वेक्टर की बिल्कुल समझ नहीं आ रहा कि ये क्या है.
हाँ, as I'm saying that for the time being, आप इसकी mechanical interpretation ले लेना. Mechanical का मतलब मेरा ये है कि for the time being, you should consider that these numbers that we call the eigenvalues, they are obtained by solving an equation like this, which involves the correlation matrix, okay? Solving this equation in which the main input is correlation matrix, you will get these 5 numbers. And then taking each of these numbers one by one and putting them into this expression, which again includes correlation matrix and the corresponding number that you have obtained, you can get the corresponding eigenvector. So this is for the time being a mechanical. I understand कि ज़ाहिर है आप चूंकि conceptual नहीं है तो आपको it is very understandable that it would be difficult to digest initially. ठीक है? तो फिलहाल मैं आपको ये कहता हूँ कि इसको न चाहते हुए भी डाइजेस्ट कर लें, इवन इफ यू हैव नो आइडिया कि ये क्या है। फिलहाल आप इसको इस तरह कंसिडर कर लें कि दे आर ऑब्टेन्ड बाय दीज टू मैथमेटिकल फंक्शंस, राइट? बट both of these functions are related with what? With the correlation matrix. अब अगर आप देखें ना, दोनों में R आ रहा है. So R is the correlation. R is the correlation matrix of our original data. And using that correlation matrix, we come up with two different functions, and those functions then give us this structure. Okay.
Thank you, sir. Okay.
So originally, because there are 5 eigenvalues, 5 numbers. So this second function that I have mentioned here, this will also give you 5 different vectors. But on the screen, you will not see all those 5 vectors because of one particular reason that I will show you right now. When we were doing this procedure under extraction, we had actually applied this rule. So this rule actually restricts the output, and it will give you the number of eigenvectors on the basis of this rule. It will just look at the list of eigenvalues. ये यहाँ पे जो आपको नजर आ रहा है ना, okay? Right. It will look at this list and will simply count how many of these numbers, जिसको हमने eigenvalues का नाम दिया है, how many of these numbers are more than 1. अब यहाँ पे कितने more than 1 हैं आपके पास? If you look at this list, 2, exactly, right? You don't need to calculate anything, just by observation. Just by observation, you can immediately say that 2 of the numbers, the first 2 numbers, 2.437, okay, this one, this first number, and this second number. So 2 of the eigenvalues are greater than 1. So what it would do, it would actually give you the eigenvectors corresponding to the first 2 eigenvalues only, which means that it will ignore the rest of the 3. That is one of the reasons when you look at the output here, the next output, okay? ये जो आपके पास output है, this one. This is actually giving you those eigenvectors. This one, which corresponds to component 1, ये जो आपको नजर आ रहा है ना, ये वाला. This is the eigenvector corresponding to this eigenvalue, 2.437. Okay. So corresponding to 2.437, when this 2.437 is plugged into this function, it gives you this vector, 0.732, 0.831, and so on, right? This is actually the eigenvector which we need for step number 3 of our PCA process. And for the second eigenvalue, 1.407, this one, okay? When this is plugged into this particular function, it gives you this second eigenvector, this one. So this second eigenvector is actually given by that. This is the first one. So these are the 2 eigenvectors. So effectively, using that rule that I have shown you, that how many eigenvalues are greater than 1, it decides the dimensionality of the data. ये जो हमारा objective number 1 है ना PCA का, which says that the number of variables to be studied can be quite smaller than the actual variables. So in the given case, using that rule of the number of eigenvalues greater than 1, the rule is actually telling us that the information available originally in terms of the 5 variables in the style of type of those 5 stocks can be reproduced or can be studied in terms of 2 new variables, right? Component 1 and component 2. So component 1 के against ये जो आपको नजर आ रहा है, this is actually the eigenvector which we need to define the first component or the first PC. And this second column that you see in this component matrix, this is actually giving us that second component. So on the basis of that, we define then the first PC, okay? And we define then the second PC. If we use our notation and we say the first PC is denoted by Y1, so what would this Y1 look like? And if the second PC is denoted by Y2, then what it would look like? The first PC would be defined by multiplying each of the number in the first eigenvector by the title of the corresponding variable and adding them up. So if I use, for example, x1 for the first variable, x2 for the second variable, okay, and so on, x5 for the last one, okay, then the first PC, although there is no need to write it like this, but I'm just writing it only for the first and last time. So the first PC is something like this. This is 0.732 x1 plus, you can imagine that you can define the others. This is x1 and plus so on. Plus the last one is 0.563 into that, okay? So this is 0.563 x5. So this is how you can just define y1 and y2. So y1 would be defined a particular linear combination in which the weights would be these. So these numbers that you can see over here, 0.732, 0.831, 0.726, they are like A1, A2, A3, A4, A5, right? Which we just saw in our previous discussion. So 0.732 x1 plus 0.831 x2 plus 0.726 x3 and so on. This gives you what? This gives you the first PC. And if you multiply these numbers with the corresponding title, x1, x2 up to x5, and add them together, so you will get the definition for the second PC. So if you want to define y2 or the second PC, how can you do that thing? Minus 0.437 x1, minus 0.280 x2, minus 0.374 x3, plus 0.694 x4, plus 0.719 x5. So therefore, this is how you obtain two new variables, which we call the two PCs from the 5 actual variables. So this is actually our objective number one. From the 5 actual variables, we have got two new variables, okay? And if you want to, yeah.
Excuse me, sir, ये Y2 की, sir Y2 की समझ नहीं आ रही है, sorry.
Y2
की सर समझ नहीं आई है.
Y2 is defined similar to Y1, okay? The numbers that you see under component 1, ये जो आपको नजर आ रहे हैं ना, 0.732 up to 0.563, these are the constants to be used by defining the linear combination जिसको हम Y1 कह रहे हैं. Similarly, these numbers minus 0.437, minus 0.280, up to 0.719. These numbers define the constants that you will be using for defining the second linear combination. So y1 is the first linear combination, y2 is the second linear combination. तो अगर आपके पास जनरल फॉर्म इस तरह है ना, फॉर एग्जाम्पल अगर आपके पास लेट्स से अगर आपके पास इस तरह आ रहा है कि y will be equal to, let's say, a1 x1 plus a2 x2 plus so on. और लास्ट में आप लिखें कि प्लस a5 x5, okay, plus a5 x5, because we have 5 variables here. So these weights a1, a2, and then you would have a3 x3, a4 x4. These weights for y1 would be obtained from this column, and these weights for y2 would be obtained from this column. So in a1, a2, a3 की जगह आप y1 के लिए first PC के लिए ये numbers लिखेंगे और y2 के लिए ये numbers लिखेंगे. This is as far as the two PCs are concerned. So if you want to define the first PC, use these constants. If you want to define the second PC, use these constants, right? So this is how we come up with our first objective, जिसको हम कहते हैं dimensionality reduction. The next important thing is, like, what is the meaning of these two new variables? The way you define y1 and the way you define y2, okay? So if you go to the book, they have given a very useful interpretation of these quantities. For example, if you look at the first PC, all the coefficients are positive and they are almost very closer to each other in size, which means they are almost equally weighted, right? So in the example in the book, they have given this particular y1 in which all the weights are almost closer to each other and they are all positive. They have considered it as the market component. The market component. इसके लिए उन्होंने नाम दिया है. If I can show you in the book, let me see where it is. Yeah, using this data, okay. If you go to the specific example in the book, they say that y1, which is an overall weighted average, can be considered as something if I can move to the particular example where this particular example has been used, okay. It is example in the chapter 8 of this book. Okay, this example 8.5, okay, in chapter 8 of this book, and they have come up with the results over there, okay. These are the names which are probably, if you look at the nature of the data, okay. So the first component is given the name of general stock market component. right, are what you call the market component. Why they call it the market component or the general stock market component? Because if you look at the nature of the constants used in the definition of the first PC, then they are almost equal to each other, closer to each other, and they are all positive, okay? So therefore, because of this nature, we say that the first PC can be considered as something like a market component, which means if you want to study the overall market activity, like in which weeks market was going up, in which week the market was going down. So the first PC can be considered as a summary or giving you an overall market situation. So that's why you can call it something like a market component, an overall index of market activity, okay? While if you look at the nature of the second component, let me show you that one. If you look at this one, you discover that 3 of the numbers are negative, while the other 2 are positive, okay? The negative sign shows one type of relationship of the actual variables with the component, something like inverse relationship, and the positive shows relationship or correlation in the same direction. But if we don't go into that thing for the time being, we would say that on the basis of the signs that we have in this second vector, we can say that the second component, in a sense, is dividing the original variables into 2 groups. The negative sign combines 3 stocks in one group, and the positive sign combines 2 stocks in another group. So 3 stocks, JP Morgan, Citibank, and Wells Fargo, they all have the negative sign here. So they, in a sense, are having one same relationship with the second component, while the next 2 stocks, Royal Dutch Shell and ExxonMobil, they have a positive sign, so they can be, in a sense, brought into one same group. So therefore, the second component, in a sense, divides the 5 stocks in our data sets into 2 groups. One consisting of 3 stocks, JP Morgan, Citibank, and Wells Fargo, and the other one consisting of Royal Dutch Shell and ExxonMobil. And if we look closely at the nature of these 2 grouping, we would discover that the first group of actual variables, JP Morgan, Citibank, and Wells Fargo, they are actually financial stocks. So they deal with one particular type of industry, which we can call financial industry. While if you look at the second group, Royal Dutch Shell and ExxonMobil, they actually deal with petroleum stocks. So they are actually dealing with another type of industry. So on the basis of this discussion, if you go to the relevant portion of the book, right, they have used this word for that, industry component, okay? Because it represents a contrast between the banking stocks, right, and the oil stocks or the petroleum stocks. So it's basically a contrast, a comparison between one type of stocks and other type of stocks. Due to this reason, they have actually used the word industry component, okay? Remember, these names like market component and industry component, they become easier when you're analyzing a data in a particular field in which you are, in a sense, a sort of expert, okay? So for example, when you will be analyzing your own data using PCA, I'm very confident that once you get something like the first PC and the second PC, and when you look closely at the nature of those variables, just like we did in the current case, when we look at the output of SPSS, right? When we look closely into the column representing the weights for the first PC, and when we look closely at the column representing the weights of the second PC, then we are able to give an appropriate name for the first PC and the second PC, okay? So if you are a person belonging to that field, so it becomes a little bit easier to give an appropriate name to the new variables. So therefore, you should not worry that much. Okay, how can we name PC1 and how can we name PC2? It depends on, for example, if you have a deeper knowledge of the underlying data, then it would become quite easier at the end to give that name. So therefore, this is what we call interpretation. So the interpretation is telling us that not only we are able to get 2 new variables from the actual 5 variables, but we are also able to give some names which give us some important information. Like the first PC can be used to study the overall market activity because it represents the overall market index, while the second component can be used to compare one type of industry with another type of industry because it divides all the stocks into, in a sense, banking stocks or financial stocks versus oil stocks. So therefore, this is one useful information which was not available from the original data. But once we bring the dimensionality from 5 to 2, we get 2 new variables which are giving us some additional feature of our data. This is called interpretation. But apart from that, one last thing with which we would end this lecture, that not only we get Y1 and Y2, which I call PC1 and PC2 from these 2 columns, but we are also asking the software that these 2 should be represented in quantitative form, right? So if I use the right-hand side of Y1 and if I use the right-hand side of Y2, the linear combination Y1 and the linear combination Y2, the software is also representing it in the form of a numeric equation, okay? And as you can see here, it is adding 2 new columns. If I just can give it proper name, if I call this one as Y1, and if I call this one as Y2, and for example, I can call this one as PC1, and I can call this one as PC2. So PC1 and PC2 are the actual labels, while in short, I have represented it by this. So you see, these 2 columns, which are now added into my data, they were previously not there. Previously, I had only the first 5 columns, X1 up to X5. Now, what is Y1? Y1 is actually the first PC. So if using the formula for Y1, using the linear combination called Y1, if I put these 5 values over there, right? Because I have got A1 X1, A2 X2. So in the expression of Y1, okay, in the expression of Y1, I have got something like A1 X1, okay, plus A2 X2 plus so on up to A5 X5. ये expression है ना, where these A1, A2, A3, they are actually obtained from the vectors that I explained in the last output. Now, starting from the first row, if you replace these X1, X2 up to X5 by these numbers, right? X1 की जगह 0.01303 ये डाल दें, X2 की जगह ये डाल दें, up to X5 की जगह. Or A1, A2, A3, they are coming from the output that we got at the end in the SPSS. So this is actually the numeric score that you will get from this expression, okay? And, okay, so these columns, in a sense, will give us the newly obtained PCs in quantitative form. अब दो चीजें हैं जो आप ज़हन में रखें. Once we get y1, y2, not only in its mathematical form, which are visible from this table, ये जो component matrix है, this is actually defining the expression for y1 and y2, because they are giving us a1, a2 up to a5 for y1, and the same a1, a2, a5 for y2. So not only we are defining it, but using this expression of y1 and y2 and starting from row number 1, plugging the values of the 5 variables for each row into the expression of y1 and y2, we come up with these two columns. So in a sense, when we reduce the dimensionality from 5 to 2, effectively we are trying to say that now there is no need to use these 5 variables, because these 5 variables are now replaced by these 2 variables. So y1 and y2 would then be used as a replacement for x1 up to x5 in subsequent analysis. चाहे वो regression analysis है, चाहे वो discriminant analysis है, चाहे वो और techniques हैं जो इसके बाद हम discuss करेंगे, right? y1 and y2 are effectively replacing the x variables, because using the PCA, we have reduced the dimensionality from 5 to 2, right? Effectively, we are trying to say that these 2 variables can give you almost the same information as is given by the original 5 variables. So with this, we just reached to the end of our discussion.
Thank you, sir.
Right. So if there is no further question, I think we can just end it over here. Baki jo material hai, I would send to all of you today. And if you have any question, you can just ask it at the start of our next discussion.
Thank you, sir.
Okay, thank you very much. See you next time.